Class, last time we was talking about systems of equations in regards to graphing, right? To find the solution to systems of equations in terms of graphing. Learn how do I graph a solution of equations. Let me take a second. Let's reflect before we go even further, just to talk about some basic stuff. So first of all, right, when we talk about a system, right, when we see this word system, all right, we need to remember a system, right? A system of equations is where we have two or more rather. I'm sorry. We have two or more equations. So this system of equations is two or more equations. So this vocabulary, this terminology is very important. You need to be able to say, when I ask you, well, what is a system? All right, what is a system? You need to be able to say that's two or more equations. Right? That's two or more equations. Right? When we talk about a solution, what is a solution to a system, right? A solution to a system, right, is a point. So it's got to be a point. It has an x value, has a y value. It's a point. A point that makes all the equations true, all right? It has to make all the equations, that makes all equations true, all right? So as we did yesterday, you need to be able to say, okay, I know that when I plug in this point, it makes all those equations true. That means that that's a solution to the system. Once again, a system is two or more equations. A solution to that system is a point that makes all equations true. Now, as you'll see, and then when you get back, there are three types of scenarios, right, regarding systems and solutions. Sometimes there is a solution where there's one solution, which is most times there's going to be only one solution. Sometimes you're going to see that there is no solution, and that's probably because they're parallel lines, right? And we'll talk more about that next week. Well, how do I know that they're parallel, or how do I know that, they have no solution? And we'll talk about that next week. And then also there's a case where they have infinite number of solutions, and that means that they're the same exact line. And we'll talk more about those details later, but I wanted to refresh your brain on what is a system as well as what is a solution. So a system is two or more equations. A solution is a point, has to be a point, has an x value, has a y value, and that makes all the equations, all the equations true. It makes all equations true. Sorry, let me write the word true. Awesome. Okay, so that's just a refresher for now on what we're talking about, how we going into it. We already talked about the very first method. So there are three methods that we are identifying, right? Three methods that we are focusing on, right? The first method, right, we talked about yesterday. That method, right, we talked about that method yesterday. That method was graphing. So graphing was one method that we found in order to find a solution. Graphing was one method. Today we're going to talk about another method. Let me just go back. Graphing was where we graphed both of the equations. Wherever they intersected, right? Wherever they intersected, this was known as our solution, right? This was known as our solution, right? So it's very easy to see, what is the solution when we go to graph them. However, when we're dealing with another method that we're going to talk about today, which is called substitution, we're not graphing them, so we can't just look and see where is the point on the coordinate plane. We have to use an alternate method to be able to figure it out. So let's look at our worksheet. Everybody should be looking at 5.2. Right, should look at 5.2 with me, and what you should see is the systems of equations substitution method. If you're not on that page, make sure you are. I think it's page 3 or 4 in the packet. Right, but it should say 5.2. Learning objective 5.2. We'll be able to solve a system of equations using the method of substitution. Okay, so let's start off with the bell work, and I know there's no bell for you to be like, oh, ding, ding, ding. But what I want you to do right now is this, and try to be honest and take your second, pause the video, and work on the bell work. All right, I'm gonna take some time, give yourself, 3 to 5 minutes, work on the bell work, right? And then after you work on the bell work, unpause it and let me go through it. Okay? All right, hoping that you was honest, right, and you paused the video, right? Hoping that you was honest and that you paused the video. Now let me go over it with you to see if we arrived at the same answers. Okay? So when I look here, it says when x is equal to 5 and y is equal to 2x minus 3, find the value of y. So this is asking me, well, x is 5. They give me y is equal to something, right, that has x in it, and they want me to find the value of y. What I'm going to do is I'm going to substitute 5 for x, right? And I know this screen may be hard for you to see. That's why I'm hoping that you are looking along in your packet, because this screen is tough. I'm not in our normal classroom. I'm in a science classroom, so their screen is a little bit lighter than ours. All right, so do your best to follow along with me, but please make sure you try to do it as we go through. I know the marker will be a little bit dark, okay? But I'm going to start off by saying, okay, x is equal to 5. Let me make it where this is just a little bit thinner. All right? I'm going to write y is then equal to 2 multiplied by x, which I know x is 5. So 2 times 5 minus 3. When I go to simplify that, 2 times 5 is 10. Right? Minus 3 is what's going to give us y. So that means that y is equal to 7. If you got this as your answer, give yourself a round of applause. You did a good job, right? Y is equal to 7. Great. Right? With number 2 here, right? Now instead of us finding y, we have to find x, and they give us a y value. So the first one had x is equal to 5. X was solved for. The second one, y is solved for, and now we have to find the value of x. So now I'm going to work backwards. So what I have to do here is this. I'd say, okay, well, y is equal to 5. So I'm going to say instead of putting y there, I'm going to substitute that with 5. So 5 is going to be equal to 2 times x minus 3. Okay? Our goal is to get x by itself. Our goal is to get x all alone. So I'm going to move this negative 3. I'm going to move it on the other side. And whatever we do to one side, we got to do to the other side. Okay? Whatever we do to one side of the equation, we got to do to the other side. So if I add 3 over here, I have to add 3 over here. So I'm going to go plus 3 on this side, plus 3 on this side. That cancels out. What I end up getting is 8 is equal to 2x. I end up getting 8 is equal to 2x, right? This is what I end up getting. I get 8 is equal to 2x. Now I have to solve for x here, right? The way I solve for x is I have to use the inverse operation. That looks to me like it's multiplication, 2 times x. So I have to use the inverse or opposite, which means I have to divide. So I'm going to divide by 2 on both sides. Divide by 2 on both sides in order to get x by itself. And I end up getting 4 is equal to x, right? X is equal to 4. So if you got x equal to 4, also give yourself a round of applause, right? So far, you have used the substitution method. Now, whether you completely understand it or not, you have, right? What you did is I said in the first one, x is equal to 5. So you said, I'm going to substitute. Every time I see an x, I'm going to substitute the value 5, right? And what you did is say, okay, I'm plugging in 5 there. And the second problem, I gave you y is equal to 5. And you said, okay, every time I see y, I'm going to substitute that value with 5. Every time I see that variable, every time I see that letter, it's going to now become the number 5. And you did it with both of these examples, right? That's the essence of the substitution method. Now, it's a little more complicated than that. And I'm going to show you in a second, well, how do I do it in terms of a system where there's 2 equations, right? Let me show you, right? Where there's 2 full equations, how do I substitute when they're not giving me x is equal to a number or y is equal to a number, right? How can I substitute it when they give me and y is equal to mx plus b form? I'm going to show you. I'm going to try to show you a couple different ways, all right? But please follow along. Take a second. If I'm going too fast, pause it, rewind it, watch it again, right? Take your time. Everyone, you should have out paper. You should be taking notes if you need to. That way you're not missing anything. Okay, so as I scroll down here, I'm going to the modeling section. Now, the modeling section is, it says this: find the solution of the system of equations using the substitution method, right? The very first thing that I see here is they told me y is equal to 4x minus 9 in one equation, and then the other equation says y is equal to x minus 3. So I have 2 equations here, right? I have 2 equations, and I want to be able to say, okay, well, what is the solution, right? Our goal is to still find the solution, right? That's our goal. We have to figure out, well, what's the solution? That's our goal. That's our end game. Always, all right? In terms of a system, whenever you're given a system, your goal is to find the solution. Now, there's 3 methods. We learned graphic, right? Now, could you plug this on your calculator? Absolutely. You plug this on your calculator, you should be able to see, you should be able to find the intersection, right? You should be able to, if you want to graph it manually, you can graph it, find the intersection. If you plug it on your calculator, you should be able to plug in y1 into y2. Then you go over to make sure it's in the right standard, right? Remember following the instructions that's on the paper from 5.1a. Then you click second, trace, go to 5, I believe, where it says intersect, and then you can enter 3 times. You should be able to see what the intersection is. X is equal to this, Y is equal to that. But that's the method of graphing. The method of substitution is different. Now, why are we learning different methods if they all give us the same answer? Because you're not sure what you're going to be given, especially on the Regents exam. It may say, look at the system below using the substitution method, right? It may say the substitution method. It may say the graphing method. It may say even elimination. Whatever method they tell you is the method that they want you to use, okay? So let's look about how to use substitution. So I know that y is equal to 4x minus 9. I also know that y is equal to x minus 3. So essentially, I'm looking at, well, y is this and y is that, right? I know this would be true if I said y is equal to y. I'm hoping that you would agree with me that this would be true. Y is equal to y. There's no question. Just like I said, 1 is equal to 1. They're the same value. They make sense. Y is equal to y. So in this case here, since y is equal to y, I can also say, well, 4x minus 9 is equal to x minus 3. Okay? I can say 4x minus 9 is equal to x minus 3. What I'm doing in essence, right, is substitution. And I'll show you in a second. Right? What I'm doing in substance is saying, okay, well, since I know that this is y is equal to that, when I see, and since I know this is y, instead of having y there, I can put 4x minus 9 is equal to x minus 3. So I substituted this here into y. I substituted all that into y to make it where now it's 4x minus 9 is equal to x minus 3. Okay? Now, if this is a little bit too fast for you, like, what? How? Take a second. Rewind it. Play it again, okay? Try to get it, because this is the main part of substitution. Because now, all I have to do is solve, really. Right? There's nothing more for me to do. I substituted already. That's the method that you got to remember. It's substitution. You are substituting the value. So here, it said y was equal to this. It said y was equal to that. So I substituted y in. Right? I said, okay, since this says y is equal to that, and the bottom says y equals this, instead of me writing y there first, let me change that to 4x minus 9 is equal to x minus 3, or y is equal to y. Now that I have that, now I'm going to go and solve for x, because there's no y's here anymore. Now it's just x, so I'm going to solve for x. Put all the numbers on one side, put all the variables on another. I'm going to move all the numbers to the right side, and I'm going to move all the variables to the left side. So what I'm going to do first is I'm actually going to move this 9. I'm going to add 9 to both sides. This cancels out over here. I get 4x is equal to x plus 6, because negative 3 plus 9 is a positive 6, right? Now the last thing I need to do here is I need to move this x over. I mean, it's not the last thing. I apologize. But I need to move the x over to the other side. It's a positive x, right? So I'm going to subtract it and get it onto the other side. So subtract x on both sides. Right? That cancels out. I'm left with 3x is equal to 6. I'm left with 3x equals 6. Lastly, now, in order for me to solve for x, I have to use the inverse. Once again, the opposite operation. That looks like multiplication to me because it's 3 times x. That means what I need to do is I need to divide now. I'm going to divide by 3 on both sides. Divide by 3 here. That'll cancel out. But whatever you do to one side, you do to the other side. We talked about yesterday. This is a scale. It has to stay balanced. If you do it to one side, you have to do it to the other side. Otherwise, the equation is completely, it's different. It's not even the same anymore. Okay? So I end up getting x is equal to 2. I end up getting x is equal to 2. Now, this is great. This is awesome because now I have x here. Now I have to find y. Just like in the bell work problem where they told you the value of one of them, and you said, okay, now that I have the value, let me go and plug that in. Now that you have the value of x, go plug it back into either one of the equations. It doesn't matter what equation you plug it into. Because if you did solve for x correctly, when you plug it into either one of these equations, it should give you the same y value. For now, let me go plug it into the first one, which says y is equal to 4x minus 9. I'm going to plug in my x value into y is equal to 4x minus 9. So I'm going to go over here. Y is equal to 4x minus 9. I'm going to plug in my 2. Everywhere I see an x, I'm going to plug in 2. Okay? So now I'm going to have y is equal to 4 times 2 minus 9. Right? This means y is equal to 8 minus 9, which means y is equal to negative 1. Means y is equal to negative 1. So now I have my x value and I have my y value. And if you checked it, you can check it once again on your calculator. Go and check it. Say, let me type in both of these equations. Y is equal to 4x minus 9. Let me also type in on my calculator. So you should be checking it on your calculator. Type in y is equal to x minus 3. When you type those in, once again, follow the steps from 5.1a, look for the intersection, look for the solution, and see if it tells you x is equal to 2 and y is equal to negative 1. If it does, congratulations, that means that we arrived at the right answer, right? If it doesn't, take a second to look back and say, maybe I typed in a button wrong. Maybe I did something. Look back and check it, right? I'm going to check my work as well to make sure this makes sense, right? And I'm going to show you how I'm going to check it in a second. But the solution here, when I write my solution, it's going to be a point. So it's going to be 2, negative 1. That is my solution. Okay? That is my solution. Okay? Okay? Let me do one more with you. I want to do one more with you. And hopefully you'll see how to do it when the numbers don't look like they're going to work. The numbers, the coefficients look a little weird. They don't look like they're as simple as y is equal to, right? Because I didn't have to just use y equals. I could have did something else, like in example 2. So in modeling example 2, I just moved over there. You see we have something different here. We have 4x minus 2y equals 2, and we have 2x plus y equals negative 5. This is still a system. A system, once again, is 2 or more equations. I'm going to repeat this throughout all these videos because I need you, when you get back, to be able to spit it out to me and tell me, well, I know what a system is because you kept saying it in the video. It is 2 or more equations. That is what a system is. And a solution is a point that makes both of these true. So if I were to check for the modeling example 1, if 2, negative 1 was the right answer, I will plug it into both of those equations. And if it makes both of them true, it is my solution, okay? In addition to checking it on my calculator. So for example number 2, right, they don't give me y equals in both of these equations. They're not written in slope-intercept form. They're written in more of a standard form, one that's like 4x minus 2y equals 2, right? Something like this. In this case here, right, I need to be able to get a variable by itself. In order for me to use substitution, I need to have either x equals something or y equals something. It doesn't only have to be y equals something. It could be x equals something as well. As you'll see on your independent practice problems that you'll have to do on your own, you might have to solve for x, and it'll be a fully expression, right? 3x minus 4, right? And you'll have to substitute that into the other equation for every time you see an x. Now in this case here, I want to work with a letter that's easy. I want to solve for a letter that's easy to solve for. Well, what do I mean by easy to solve for? One that doesn't have a coefficient greater than 1. If I see in this case, right, that there's in both of these equations, and one of the equations, that there is a variable that doesn't have a coefficient greater than 1, I want to solve for that variable. So for example, well, what do you mean, Mr. Woodford? Look at the second equation here. It says 2x plus y equals negative 5. 2x plus y equals negative 5. That tells me, okay, great. In this equation, the x has a coefficient of 2. The x has a coefficient of 2. The y has a coefficient of 1. That's what you're looking for, right? Because that means I can solve for y there without having to divide or play around with anything. I can just solve for y by moving the x's over to the other side. In the first equation, the x has a coefficient of 4, and the y has a coefficient of negative 2. So that one doesn't have a variable I can solve for easily, but the second equation does. So what I want to do is this. I want to rewrite the second equation only. I'm going to rewrite the second equation only, okay? And what I'm going to do here is this. I'm going to solve for y. I'm going to solve for y. When I go to solve for y, I'm going to move that 2x over to the other side. Since this is a positive 2x, I need to subtract it. So I'm going to subtract 2x here, which will cancel that out, and subtract 2x over there. Remember, once again, that negative 5 and that negative 2x, they're not friends. They're not like terms. They won't be hanging out and becoming one together. They are different terms. So in that case here, I have y is equal to, and you can write negative 5 minus 2x, right? You can write that, but because I like slope-intercept form, I'm going to write negative 2x minus 5, okay? Negative 2x minus 5, okay? Once again, if I'm going a little too fast for you, you feel like, Mr. Warford, this is more than I can handle, slow down, pause the video, rewind it. Take a second to really understand what I'm doing, okay? So I solve for y. Y is equal to this. Awesome. Now that I have y by itself, what I need to do is say, okay, I'm going to substitute yn to the first equation. I'm going to substitute this y here. I'm going to substitute that y into this y here, right? I'm going to substitute n right there. So when I see that y in the first one, I'm not going to write y. I'm going to write negative 2x minus 5. Okay, so let me start to write the first equation. So it says 4x minus 2. Now it's going to be y there. It's supposed to be y, but I'm not going to write y. I'm going to write negative 2x minus 5. Okay, negative 2x minus 5 is what I wrote. Awesome, right? Equals 2, because that's what the full expression says. 4x minus 2 times y. I'm substituting y with negative 2x minus 5 is equal to 2. Okay? Now that I have this, awesome. Now it's time for you to remember your distributive property. Remember the distributive property. Also remember that that number on the outside also includes whatever symbols in front of it. And now use the distributive property to be able to solve this problem correctly. Okay? So when I go to use the distributive property here, I'm going to say, oh, that negative 2 has to be multiplied by this negative 2x, and it has to be multiplied by that negative 5. Right? So when I go to do that, what's going to happen is this. I'm going to get my 4x right here. Right? That's going to be my 4x. Okay? But then what's going to happen is negative 2 times negative 2x, that gives me a positive 4x. Right? Negative 2 times a negative 5 gives me a positive 10. And that's going to be equal to 2. Okay? So what I end up getting now is this. What I did is I distributed that negative 2. I got a positive 4x. Distribute that negative 2, I got a positive 10. Right? This is what I ended up getting, which is awesome. This is great. Because now what happens here is I'm able to say, wonderful. Now that I have this, I'm able to now combine like terms and solve for x. Once again, we are able to combine like terms, solve for x. After we get x equals to a number, we plug it into either one of the equations, and we solve for y. All right? So let's go. Let's find out what x is equal to. So now in order for me to find out what x is equal to, I combine like terms. I see 4x and 4x. That gives me 8x plus 10 equals 2. I want to get x by itself, so I got to get rid of the number first, right? We're going to add or subtract first, and then we're going to do it multiplying or dividing. So I'm going to subtract 10 on both sides. Subtract 10 on both sides, right? Those 10s cancels out. I get 8x is equal to negative 8. That's an 8, okay? 8x is equal to negative 8. I then divide by 8 on both sides. I see that x is equal to negative 1. Awesome. Yes, it's a lot of work just to get x by itself. Whoa, Mr. Winfrey, we used up all this space just to solve for x. Yes, we did. But now it shouldn't be too hard to find y. Why? Because look here. We already have y is equal to this thing here. So if we take this right here and we go to plug that in for x, we should be able to figure out what y is rather easily, right? So now if I plug it in here, I go y is equal to negative 2 times x, which I'm going to substitute with negative 1, minus 5. And if you solve this correctly, you should get negative 2 times negative 1 gives you a positive, because a negative times negative gives you a positive, so that's a positive 2. So I get 2 minus 5 here. And that's what y is equal to. So y is going to be equal to a negative 3. Right? Once again, even though we found x, we found y, we got to write our solution. Right? Our solution to this problem, our solution is going to be negative 1, comma, negative 3. Now, it's really ironic that I'm writing this right underneath where it says solution. All right? But if you notice something, that the steps that are over here, right, are steps to solve the same problem that we just solved, right? They're steps to solve the same problem we just solved, right? The first thing they did is they found the lone variable, or they solved for a variable that had a coefficient of 1. In this case, they went and they solved for y, just like we did. However, when they solved it, they made it negative 5 minus 2x. We made it negative 2x minus 5. They're the same, right? Now that they did that, they substituted n to y. So they did exactly what we did. They went to the first equation and they substituted n for y. Okay? So they got 4x minus 2, parentheses, negative 5 minus 2x equals 2, just like us. They distributed. They got the same thing as us. They combined like terms. Then they subtracted 10 on both sides. They divided by 8. They solved for x. Now that they solved for x, they went in to go and plug that into the first one that's up here that they solved for y, and they got y is equal to negative 3 as well. All right? If you have a question, take time. Pause the video. Reflect on what we did. If you have a question, put it in the comments below in the Google Classroom page. That way I'm able to say, okay, great, this is your question. Let me aim to answer that, all right? We're going to do a little more practice next week when you get back in school, but I want you to complete your worksheet right as best as you can, following these steps. Take this time, rewind the video, get a full understanding of it. Also go on Delta Math, practice a little bit, get as much practice as you can with substitution, right? They won't all have may not all have a lone variable. You may have to solve for y or solve for x, right? But your job is to then be able to say, okay, great, now that I solved for them, let me go and substitute them into the other equation. All right, so let's look over. If you want to be done with the worksheet, say, okay, Mr. Winford, I get it. We're done. You can end the video now, begin the work on the worksheet. However, if you want to get a little bit additional help, stay with me just for a little bit longer. Let me go over each problem and tell you which ones you could solve for. For example, here, they solve for y. All you got to do is plug that in. For the second equation to solve for y, plug that into the first equation. Number 2, right, they have y is equal to a number. Plug that into the second equation, okay? Remember, you're looking for a solution, so it's got to be a point, okay? Number 3, you're going to have to solve either for x or y. Now, in number 3, both x and the y on the second equation have a coefficient of 1. Now, the y in that case has a negative 1 as a coefficient. So maybe I would solve for actual x. I would solve for x. Move that negative y over to the other side, get x is equal to y plus 13, then plug it into the first equation for x. Number 4, I would also solve for x. The first equation has a coefficient for x of 1. Everything else has bigger coefficients. Number 5, you'll plug in the value for x. Number 6, you should plug in the value for y. Number 7, I would solve for x. Now, in the second equation, it says negative x plus 2y equals 40. I would move that 2y over to the other side and then divide by a negative 1 to get x by itself. After I got x by itself, I would plug that into the first equation, okay? Number 8, they gave you what y is equal to. Plug that in. Number 9, the very first equation says 4x minus y is equal to 20. I would solve for y there in the first equation. Once again, move that 4x over, divide by a negative 1. Remember, you don't just have negative y. That doesn't work. Solve for y or solve for x. Not negative y, not negative x. 10, I would solve for x in the second equation, which is easy. Just move that negative 5y over. 11, I would solve for y in the first equation. It's a positive y, so all you got to do is move that 4 over. 12, I would solve for y in the second equation. Move the 2x over. Okay? All right, and I believe that might be all. Let me see. Okay? That is it, okay? All right, so take this time, reflect over. If you have to rewatch it, fast forward, past the parts that you understand, but really get a good grip of this understanding, as well as do your practice work on the independent practice, as well as your Delta Math work. Hope you guys enjoyed the video. I will see you guys next week. Good luck on your midterms, regents, whatever you're taking this week, or if you're just home relaxing, take the second to please complete all your assignments for this class, okay? Next week, we're going to go through this really vigorous, and we're going to have a great time. Have a great day, guys. Bye-bye.